Good morning, guys. Good morning. Good morning, everyone. Hey guys, good morning. So in this session now, like we are going to particularly focus on the NEET PYQs, like previous year questions. Okay. So let us start with the question where we left in yesterday's session. Yes. Question number, yeah. Slide number 70. Okay, that's it. Yeah, this is the question, today's question. Okay, so from this we'll start. A capacitor of a capacitance C is equals to 900 is charged rarely by 100 volt battery. Okay, like battery B is there. Okay, then as shown in the given figure, then B is the disconnected from the battery and connected to another uncharged capacitor of C is equals to 900 as shown in the figure B. Okay, then the electrostatic energy stored by the system is, I need to find the electrostatic energy stored by the system. So let me take a pen here, wait a minute. Yes, what was the given terms here? First of all, I write it. The given things are C is equals to 900 picofarad, which is nothing but 10 power minus 12 F. Okay, and volt battery at V is equals to 100. So from this can I find the charge? How much charge? Q is equals to CV, right? Q is equals to CV, where C is nothing but 900 into 10 power minus 12 into 100. V is nothing but 100, right? So 9 into 10 power minus 12, 1, 2, 3, 4, 4 zeros, so 10 power 4, which is nothing but 9 into 10 power 8 minus 8. Okay, it is minus 8. Now if I see here, no, charge is conserved. Charge is conserved. Yes, this one is conserved. Like charge, I will say charge is conserved. Now I need to find the energy stored in the second battery, no, like the battery has been disconnected, no, and it has been connected to the another thing. Now I mean the capacitance, yes, it is series, no, I mean it is parallel capacitor. So C plus C, which is nothing but 2C, the new capacitor is 2C, right? I need to find the voltage, how much voltage it is, the electrostatic energy stored by the system. Yes, first I will find the voltage and then I will find the energy. Energy is nothing but of CV square, right, of CV square. So let me take it. Yeah, so Q is equals to CV, right? Q is equals to CV, where like C dash I will take, C dash and V dash. Energy is conserved and C dash is 2C and V dash I will keep as it is. I need to find the V dash, new voltage. Initially the voltage was 100, but it has been disconnected and connected to another thing. So it has become C plus C 2C. Okay, C plus C 2C. Okay, one capacitance and another capacitance. So parallel capacitance. So C plus C 2C has been came. C dash is nothing but, this is C dash, which is nothing but C dash. Okay, now the energy has been conserved, I mean charge has been conserved. This is 9 into 10 power minus 8 is equals to 2 into how much? It is 900, no, 900 into 10 power minus 12 into V dash. So from this I can find the V dash value. From this I can find the V dash value. So from that I can say that energy is equals to, E is equals to of CV dash. Okay, so from here I can get the energy value. So first I need to find the value of V dash. Value of V dash. Okay, yeah, V dash is here. So from this V dash I can substitute the value here of CV square. So what is the answer you are getting? What is the answer? What is the answer? Yeah, you can calculate it now. It's easy to find, right? Only the calculation part is left out. So here I can take it is nothing but 9 into 10 power minus 8. So 9 into 10 power minus 8 in 2 into 9 is 18 So divide by 1800 into 10 power minus 12 is equals to V dash. Now if I see here, this 1 sir and this is 2 sir. Okay, so what I will get? 1 by 2 into 10 power minus 8 into 10 power 12, only 12 will come, is equals to V dash. So here 10 power 4 divided by 2, this is V dash value. Take this V dash value and substitute in this equation. E is equals to of CV square. C is nothing but 900 into 10 power minus 12. V dash I will get 10 power 4 by 2. You will get the answer for the equation, that is energy stored in the new system. Is it visible? The question is fully visible, right? Let me arrange it. Wait. Yes, I guess it's visible now. We'll go for the next question. So the energy, like what are the formulas we have learned here? So one is capacitance in parallel, C plus C. So what will be the capacitance in series? 1 by C is equals to 1 by C1 plus 1 by C2. Okay, and second formula, Q is equals to CV, charge is equals to C into V, and energy is equals to of CV square. I mean this is CV square. Okay, of CV square. Okay, so 1, 2, 3. 3 formulas we have learned from this question. We'll go for the next question. Okay, yes. So equivalent capacitance of the combination shown in the given figure. Okay, so if I see here now, can I take this as series, this one as series, and if I take this one and this one will be in parallel, right? So first one I will consider as this as series, and the resultant will taken to this as a parallel thing. So what can I do? 1 by capacitance in series should be equals to 1 by C plus 1 by C, which is nothing but C plus C by, I mean C square, right? C square. So which is equals to 1 by Cs is equals to 2C by C square. C and C will get cancelled. So capacitance in series is nothing but C by 2 we got. So this is the resultant we got. I will take this resultant and compare with this one. So that one will be in parallel condition. See, this is the thing. This is Cs and this is C. Now these both are in parallel, right? These both are in parallel. Am I right now? Now C parallel, that is C by 2, no? C parallel should be equals to Cs plus C, which is nothing but C by 2 plus C. So C plus 2C by 2, which is nothing but 3C by 2. This is the equivalent capacitance. What is the option given? A is C by 2, B is 3C by 2. Option B is the correct answer. Go for the next question. Yeah, I hope you got the answer right. You understood the method also. Like first one we have taken into series. Series formula is 1 by C is equals to 1 by C1 plus 1 by C2, and parallel formula is equals to C1 plus C2. Okay. The next question is, okay, a spherical conductor of radius 10 centimeter has a charge of 3.2 into 10 power minus 7 distributed uniformly. What is the magnitude of electric field at a point 15 centimeter from the center of the sphere? Okay. So, what is the formula for the electric field? Electric field 1 by E is equals to 1 by 4 pi epsilon naught into Q by R square, right? Q by R square, right? Am I correct? Q by R square? Yes, it's Q by R square only. Right now? I'll write it properly. E is equals to 1 by 4 pi epsilon naught Q by R square. So, what is the value of Q is like 1 by 4 pi epsilon naught is given. It is 9 into 10 power 9, like right now. So, it is 9 into 10 power 9. What is the charge is given? 3.2 into 10 power minus 7 coulomb divided by R. What is the value of R? It is electric field at a point 15 centimeter they are asking, no. So, 15 centimeter, convert it into meter. So, 0.15 the whole square, 0.15 the whole square. So, when I calculate this one, I will get the answer for the electric field. That is what they are asking, no, electric field, right. So, what will be the answer? 9 into 10 power 9, 10 power minus 7 will be 10 power 2 into, I will consider as this is 9 into 32 into, and this one will become 10. 10 power 2, no, 1 0 I have taken to point here. So, divide by 15 square is 225, right. 225 divided by 2 zeros, so 10 power 4, 10 power 4. So, what is the answer? 9 into 32 into 10 into 10 power 4 divided by 225. So, if I calculate this one, I will get the answer for the electric field. If I calculate that one, I will get the answer for the electric field. Can we go for the next question? Can we go for the next question? Yes. A hollow metal sphere of radius r is uniformly charged. The electric field due to the sphere at the distance r from the center. Okay. So, when we consider a distance r, no, when we take inside this electric field, like inside the sphere, no, it will become 0 inside the sphere. Yes, it becomes 0, and when I take greater than r, it is E is equal to 1 by 4 pi epsilon naught into Q by R square. Yeah, can I write that one? The same thing, whatever formula we have seen in the last problem, the same formula we are going to use here. So, inside like R is the distance I am considering, right? R is the distance. So, radius of the sphere is R. When it is less than, it's inside, no. When it is less than R, capital R, it is inside. So, inside electric field will be 0, and for outside, no, if R is greater than R, so E is inversely proportional to R square, where E is equals to 1 by 4 pi epsilon naught q by r square, right? So E is inversely proportional to r square. So when E increases, sorry, r increases, E decreases, right? R increases, E decreases. So 0 as r increases for r less than r, decreases as r increases for r greater than r. So here if we see, no, for this case E is equals to 0, and for this case, no, if r increases, E decreases, r increases, E decreases. So 0 as r increases for r less than r, increases as r increases for r. No, option B is also wrong, option C and option D is wrong. Option A is the correct answer. 0 as r increases for r less than r, decreases r increases for r greater than r. So they are asking about the electric field. So option A is the correct answer. Option A is the correct answer. We'll go for the next question. The next question, yes. A capacitor is charged by a battery. The battery is removed and another identical uncharged capacitor is connected in parallel. Okay. The total electrostatic energy of resulting system. So in parallel, no, when we talk about the parallel, the voltage will be decreased, right? Voltage will be decreased. So connected in parallel, they are saying V will become V by 2. Yeah. So V becomes V by 2 when it connected in parallel. When it connected in parallel. So what will be the initial energy? Initial energy is equals to half CV square, right? Half CV square. What about the final energy when it connected in parallel? So E dash will be equals to half C V by 2 the whole square. Am I right? No. When like it was in V, when it connected in parallel, it becomes V by 2. So I'll take half C into V by 2 the whole square. So what will be the answer? 1 by 2 into, yeah, V by 2, no? Yeah. So how much time it becomes? Increases by 4 times now. Yeah. So 1 by 2 into C V square by 4. V square by 4. So take 1 by 4 commonly outside. 1 by 4 commonly outside. So it becomes 1 by 2 CV square. Half CV square is nothing but E. Half CV square is nothing but E. So E will be 4 times E dash. E will be 4 times E dash. That's it. Increases by a factor of 4. Option C is the correct answer. No. This is, they are asking about the electrostatic in resulting. No. So it becomes, yeah. It's correct. We'll go for the next one. Yes. The next question. Okay. A conducting sphere of radius R is given a charge Q. The electric potential and electric field at the center. So electric potential at the center is 0, obviously, right? Potential will be 0 at the center. What about the electric field? It is 1 by 4 epsilon naught Q by R square. That's it, na? So what will be the answer? Option A will not come. No, 1 by 4 pi epsilon naught into Q by R. No, it won't come because potential is 0. The option C is there, 0, and both 0 will not be there because electric field at the center 1 by 4 pi epsilon naught into Q by R square, right? Yes. Right. Wait. They are talking about the potential, no? Potential and electric field, right? Yes, potential will be there. Potential will be there. So option D will be the answer. Electric field will become 0 at center. Electric field will become 0 at center. Okay. So potential will be equals to 1 by 4 pi epsilon naught. What is that? Q by R. So electric field will be 0 at center. This is about center. Okay. And this part of the question is not visible. I'll arrange it. I guess it's visible right now. Okay. We'll go for the next question. We'll go for the next one. Yeah, you can copy down or you can take the screenshot of that. We'll go for the next. Okay, the next question. 10 resistors, each of resistance R connected in series to a battery of EMF E and negligible internal resistance. Then those are connected in parallels to the same battery. The current is increased in N times. The value of N is, okay, I need to find how much the value of N. So first thing, it has been connected in like series, no, 10 resistors in series. Then what will be the answer? Rs will be equals to 10R. Okay, what about the current? V is equals to IR. So where I is equals to, EMF is given as E, so E by 10R. Okay, this is for the series, no, series. What about the parallel? Parallel in the sense 10 resistors are in parallel, then R will be equals to R by 10, right? R by 10. Now I need to find the, yes, I need to find the current. Can you give the answer for this question? Yeah, for this also I need to get current now. So I is equals to, what is E? E by R by 10, right? R by 10. R by 10. Where it will become 10 E by R. This is for series and this is for parallel. So they are asking about the parallel to this. Okay. So N is equals to I parallel by I series. What is I parallel here? 10 E by R, no, 10 E by R by, what is series? E by 10 R, right? No, E by 10 R. So what will happen? It becomes reciprocal. I mean 10 E by R, correct. Reciprocal of that. Yeah, it becomes 100 times. That's the answer. That's the answer. 100 times it becomes. I need to find the value of N, that's it. So I have taken I parallel and I series. So 10 resistor in parallel in the and series in the sense R 10R and parallel in the sense R by 10. That's it. I'll substitute the value in V is equals to IR. Can we go for the next question? Next question. Yes. As temperature increases, the electric resistance increase for both conductor and semiconductor, decrease for both conductor and semiconductor, increase for conductor but decrease for semiconductor, decrease for conductor but increase for semiconductor. Which of the correct option in the given question? Yes. So as the temperature increases, no, as the temperature increases for conductor, resistance increases with temperature. For conductor, resistance increases with temperature. For semiconductor, obviously decreases. Yeah, that's the correct. Option C is the correct answer. Yes, option C is the correct answer. We'll go for the next question. A solid which have the negative temperature coefficient of resistance are semiconductors only, insulator and semiconductors, metals, insulators only. So which of the correct option here? It is semiconductors. Only semiconductors is the answer. Semiconductor is the answer. Yeah. The next question. Yeah, these are the theory based question. No need to solve anything. This also theory based question, and this also the theory based question. Next question is, a resistance of a wire is R ohm if it is melted and stretched to n times its original length, its new resistance will be. Okay, this one we should solve, right? What is the formula for the resistance in terms of length and area? If length increases, area decreases. Rho L by R, no? Is it? Length increases, area decreases. R is equals to rho L by A. Rho L by A. Here what they are saying, so it is melted and stretched to n times, right? So R dash will be equals to rho NL by, so A will become A by 2, A by N, no, A by N. So from here, this is the original resistance. Now what can I say? N square rho L by A, which is nothing but N square R. So this is the answer. N square R is the answer. Option A. Option A is the answer. So we'll see one of the final question in this session. I guess it will be interesting question, right? The potential difference between the point A and point B is given in the figure. I need to find the potential difference here. So when I am coming from A to B, so what will happen, like current is going in this direction, in the right direction, okay, in the same direction it's going. If it's coming in opposite direction, I can consider as positive. When I am going from this direction to this direction, no, current is also in the same direction, so I should consider as a negative. So this one, 2 into 2 will become 4, like V is equals to IR, okay. So V will become 2 into 2, which is nothing but 4 volt. Here it is 3 volt, and for this one again 2 into 2, no. So this is V1, I consider V2 will be equals to 2 into 1, which is nothing but 2 volt, okay. Now I am going from point A to point B, current also in same direction, so VA minus VB will be equals to, so same direction in the sense, minus 4 plus 3, this one will become 3, no, and minus 2. So answer will be minus 4 minus 2 minus 6 plus 3 minus 3. Minus 3 is the answer. Yeah, I hope you got the answer for this question, right? You understood the question. So we'll stop up to here. We'll continue with the next session, that is 100 days challenge of the physics, which will start exactly at 11:50. Okay guys, take a short break and come back at 11:50 exactly. Bye bye.